The rock remembers everything. That is what geology teaches. That is the foundation of the science. The strata of the earth preserve a record of events that happened before any human being existed to witness them, before any instrument was built to measure them, before any mind existed to ask what caused them. The rock does not lie. The rock does not forget. The rock contains, in the ratios of its isotopes and the chemistry of its molecules and the distribution of its minerals across layers that were deposited one on top of another over millions and billions of years, a complete account of everything that has ever happened at the surface of this planet. And in 2018, two of the most credentialed scientists working in their respective fields, Gavin Schmidt, director of NASA's Goddard Institute for Space Studies and one of the most cited climate scientists on Earth, and Adam Frank, astrophysicist at the University of Rochester and a leading researcher in astrobiology, published a paper in the International Journal of Astrobiology that asked a question so specific and so disturbing that most of their colleagues have spent the years since doing their best not to think too hard about the answer. The question was this: if an industrial civilization had existed on Earth millions of years before our own, would we be able to detect it? Their answer, after a careful and rigorous analysis of what the geological record preserves and what it destroys, was essentially, probably not. The traces of a short-lived industrial civilization, one that lasted even a few thousand years, burned fossil fuels, yes, altered the chemistry of the atmosphere, generated industrial waste, would, after tens of millions of years, be indistinguishable from a particularly severe episode of natural climate disruption. The plastics would be gone. The metals would be dispersed, the structures would have eroded. What would remain is a thin layer of chemical anomaly in the rock, elevated concentrations of certain metals, a specific pattern of carbon isotope ratios, a spike in temperature proxies. And those chemical anomalies would look, to a scientist examining them, without the prior knowledge that they came from an industrial civilization, like a particularly intense volcanic episode or a large impact event. This is not a fringe hypothesis. This is a paper by two credentialed mainstream scientists published in a peer-reviewed journal, funded by no one and sought by no one. The acknowledgments section of the paper reads, "No funding has been provided nor sought for this study. Nobody paid for this question to be asked. Nobody is paying for it to be answered." And then you look at what the rock actually contains. 56 million years ago, something happened to the Earth that climate scientists call the Paleocene-Eocene thermal maximum, the PETM. In the span of what, geologically, is an eye blink, perhaps 5,000 to 20,000 years at the outside, and possibly much shorter, the global temperature rose by between 5 and 8 degrees Celsius. The carbon isotope ratio of the atmosphere shifted by more than 3 to 4 parts per thousand in the lighter direction. The specific signature of a massive injection of carbon that had been sequestered in organic form is exactly the signature you would expect from burning fossil fuels. Ocean acidity spiked. Between 30 and 50% of benthic foraminifera, the tiny shelled organisms living on the ocean floor, went extinct in what is now called the largest mass extinction of marine organisms in the last 66 million years. The carbon release was, at minimum, 3,000 to 6,000 gigatons of carbon, roughly comparable to burning all known reserves of coal, oil, and natural gas currently estimated to exist on Earth. 30 years of research, hundreds of papers, debates at every major climate conference in the world, and there is still no complete, universally accepted natural explanation for the PETM. The leading candidate is the intrusion of magma from the North Atlantic igneous province into organic carbon-rich sediments, releasing carbon in a process somewhat analogous to a very large volcanic eruption. But the timing doesn't fully work. The rate of carbon release implied by some of the finest resolution sediment records, including a 2013 paper by Wright and Schaller in the journal Science, analyzing 13 annual layers in a drill core through the Marlborough clay in New Jersey, suggests the carbon input could have happened in as little as 13 years. 13 years. Not 5,000 years, not 20,000 years, 13. If that interpretation is correct, and it remains disputed, the PETM was not a slow volcanic release. It was a sudden, catastrophic injection of carbon into the atmosphere at a rate comparable to or exceeding the current rate of human industrial output, occurring in what amounts to a geological instant. and leaving behind the same chemical signature that our own civilization is creating right now, 56 million years later. Schmidt and Frank wrote, "Almost all changes found so far for the PETM are of the same sign and comparable magnitude as the hypothesized Anthropocene signature. Same sign, comparable magnitude, the chemical fingerprint of an industrial civilization. And one of the finest resolution analyses of the PETM suggests it happened in 13 years. Let me be specific about what the Silurian hypothesis does and does not claim, because the distinction matters. Schmidt and Frank are not claiming that the PETM was caused by an industrial civilization. They explicitly state that they strongly doubt any previous industrial civilization existed. Yet what they are claiming is more precise and more disturbing. If a civilization had existed and had caused an event like the PETM, we would not be able to tell the difference. The geological record is not capable of distinguishing between a natural carbon injection event and an industrial one after tens of millions of years. The chemical signatures converge, the artifacts are gone, only the chemistry remains, and the chemistry of the PETM remains unexplained. Now consider what Schmidt and Frank identified as the specific geological signatures that would survive for tens of millions of years if humanity disappeared tomorrow. Plastics would not survive in their current form. They would fragment and degrade into chemical residues. But certain persistent organic pollutants, the chlorinated compounds like PCBs and dioxins, would survive in anoxic sediment environments for periods measured in millions of years. Synthetic nitrogen compounds, particularly those associated with industrial agriculture, would alter the nitrogen cycle in ways detectable in isotope ratios. Certain heavy metals, vanadium, zinc, molybdenum, chromium, are released by industrial processes at rates far above natural background levels, and spikes in these metals in sediment records are one of the markers of the Anthropocene. The PETM shows spikes in exactly these metals in many sediment sections. Plutonium-244 has a half-life of approximately 80 million years, in that it does not occur in nature except as a product of supernova nucleosynthesis in quantities so small that any detectable concentration of Pu-244 in geological sediments must come from artificial nuclear processes. After 56 million years, any Pu-244 deposited by an industrial civilization would retain approximately half of its original quantity. It would be detectable. The PETM sediments have not been specifically searched for Pu-244. This is not because no one thought of it. Schmidt and Frank specifically suggested as a potential test. It has not been done. No one is funding it. Now, move forward in time. Move from 56 million years ago to 12,900 years ago. A moment close enough to human memory that some researchers believe the myths and stories that describe it are not myths at all, but records. Something happened at the end of the Younger Dryas period, the geological interval that marks the sudden termination of the last ice age. The transition from the Younger Dryas cold period to the current warm Holocene was itself sudden. Average temperatures in Greenland rose by approximately 10 degrees Celsius in as little as a decade, one of the fastest climate transitions in the geological record. But what happened at the beginning of the Younger Dryas, approximately 12,900 years ago, is the more disturbing puzzle. In 2007, a team of researchers led by Richard Firestone at Lawrence Berkeley National Laboratory published a paper in the Proceedings of the National Academy of Sciences describing what they called the Younger Dryas impact hypothesis, the proposal that a large cosmic impact or aerial explosion, a comet or asteroid fragmenting in the atmosphere or on the ice sheet, had deposited a layer of distinctive materials across a wide area at precisely the time when the Younger Dryas cold period began. The materials they identified were magnetic spherules, tiny glass and iron spheres characteristic of high-energy impact melting, and nanodiamonds, tiny diamonds formed under the extreme pressure of an impact, and elevated iridium concentrations similar to the iridium layer that marks the end Cretaceous impact 66 million years ago. This layer has since been identified at more than 50 sites across 4 continents: North America, Europe, Asia, and the Middle East. The specific combination of markers, the nanodiamonds, the magnetic spherules, the cosmic impact chemistry, is consistent across all sites at the same stratigraphic level, dated to approximately 12,800 to 12,900 years before present. The Younger Dryas impact hypothesis is contested. It is not universally accepted. Some researchers dispute the interpretation of the evidence, arguing that the spherules and nanodiamonds could have natural terrestrial origins, or that the dating is not as precise as claimed. The scientific debate is ongoing and vigorous, but a 2023 meta-analysis published in the journal Scientific Reports, combining data from 50 sites across the 4 continents, found consistent evidence for the impact layer at all sites, and concluded that the probability of a natural non-impact explanation was extremely low. At 12,900 years ago, there were human beings on Earth, not Homo sapiens at our earliest. Those go back to approximately 300,000 years ago. But anatomically modern humans, behaviorally modern humans, humans with language and culture and tools and, by some evidence, social structures of significant complexity. The Clovis culture of North America, one of the first well-documented human populations in the Americas, disappears from the archaeological record at approximately this horizon. North American megafauna, mammoths, mastodons, dire wolves, American horses, American camels, short-faced bears, underwent a mass extinction at approximately this horizon. The impact layer, the extinction, the end of Clovis, all at the same moment. If a significant cosmic impact or airburst occurred at 12,900 years ago, it would have been the most catastrophic event experienced by any human civilization in the entire history of our species. Not a local catastrophe, a global one. Sudden climate disruption, massive fires in North America generated by the impact, ejecta raining across continents, the destabilization of the ice sheets that ultimately drove the meltwater pulse that raised sea levels by tens of meters in the following centuries. This brings us to the water. There are more than 500 documented flood myths in the archaeological and anthropological record. Stories from cultures on every inhabited continent, separated by thousands of miles and thousands of years, is describing a catastrophic inundation of water that destroyed a previous world and from which only a small remnant of humanity survived. The mythological pattern is so consistent: a great flood, a warning, a vessel or high ground refuge, a remnant who carries forward the knowledge of the destroyed world, that researchers like geologists William Ryan and Walter Pittman of Columbia University have proposed that these myths preserve in narrative form the memory of actual geological events, the flooding of the Black Sea Basin approximately 7,500 years ago, or the rapid sea level rise of the early Holocene that inundated continental shelves worldwide. Between approximately 20,000 years ago, the peak of the last ice age, and approximately 6,000 years ago, sea levels rose by approximately 130 meters globally as the ice sheets melted. On 130 meters, the continental shelves that were dry land during the Ice Age, vast territories that supported human populations adjacent to the modern coastlines of every continent, were submerged. The Doggerland Plain that connected Britain to continental Europe, the Sundaland platform connecting the islands of Southeast Asia, the Beringia land bridge connecting Asia to North America, all of them submerged, all of them, if they supported human settlements of any kind, destroyed by the rising water. Whatever existed there is gone, under 130 meters of ocean, inaccessible to conventional archaeology, and the people who fled the rising water carried their memories in the only form that survives catastrophe: story. Now we arrive at Göbekli Tepe in 1994. As a Kurdish shepherd noticed a limestone surface protruding from a hillside in southeastern Turkey near the modern city of Şanlıurfa. German archaeologist Klaus Schmidt began excavations in 1995 and continued until his death in 2014. What he found, what continued to emerge from the hill over decades of excavation, was a series of stone enclosures, each constructed from T-shaped limestone pillars weighing up to 20 tons, carved with elaborate reliefs of animals: foxes, scorpions, vultures, crocodiles, wild boar. The largest enclosures are over 20 meters in diameter. The entire site covers an area of approximately 9 hectares. Göbekli Tepe was built approximately 11,500 to 10,000 years ago. This is not in dispute. The radiocarbon dates are clear and consistent, and this is what does not add up. The people who built Göbekli Tepe were, according to every model of human prehistory that existed before this site was excavated, hunter-gatherers. The construction of Göbekli Tepe predates the development of agriculture, pottery, writing, and settled civilization by thousands of years. Everything that archaeologists believed about the relationship between social complexity and monumental construction, the theory that you need cities, you need surplus food, you need organized labor, you need complex social hierarchy before you can build something like this. Everything that theory predicted was violated by Göbekli Tepe. Hunter-gatherers, according to the standard model, live in small nomadic bands following their prey. They do not organize tens of thousands of person-hours of quarrying, transport, and carving of 20-ton limestone blocks. They do not create iconographic programs sophisticated enough to encode, as some researchers believe, astronomical knowledge of precession, the slow wobble of Earth's axis that shifts the positions of the constellations over a 25,000-year cycle in the layout of animal carvings on the pillars. And then, at approximately 10,000 years ago, whoever built Göbekli Tepe deliberately buried it, not abandoned it, buried it. They filled the enclosures intentionally with debris, stone fragments, animal bones, tools. In a way that preserves the structures from erosion, they buried it as if they knew it needed to be preserved, as if they knew what was coming and they were protecting a record. This is the most disturbing detail about Göbekli Tepe. Not that it was built, that it was hidden. Klaus Schmidt himself noted that the intentional burial was not the behavior of a civilization abandoning a site. It was the behavior of a civilization protecting something for the future. He never specified what they were protecting it from. The timing of the burial, approximately 10,000 to 10,200 years ago, coincides with the period following the Younger Dryas climatic catastrophe, when agriculture was being adopted for the first time and the world was reorganizing itself around a different way of living. The people who buried Göbekli Tepe may have been the survivors of a catastrophe, preserving for whoever came after them the evidence of a knowledge tradition that the catastrophe had nearly destroyed. Or they may have been the descendants of people who already knew that catastrophes come, had come before, and would come again. The mirror is the thing that should disturb you most, not what happened 56 million years ago, not what happened 12,900 years ago, not what Göbekli Tepe implies about what came before it. The mirror. Schmidt and Frank closed their 2018 paper with an observation that receives almost no attention in the coverage of the Silurian hypothesis, possibly because it is too precise and too uncomfortable to engage with directly. They noted that our own civilization, the current human industrial civilization, is creating exactly the geological signature that they describe as the footprint of a short-lived industrial civilization. The carbon isotope anomaly, the heavy metal spikes, the nitrogen cycle disruption, the rapid warming event. We are writing into the rock right now at a rate faster than any natural process has ever written. As the exact chemical record that would, 56 million years from now, look to any scientist examining it exactly like the PETM looks to scientists examining it today. We are the PETM. And if our civilization ends in the next few thousand years, not in a distant speculative future, but in the next few thousand years, which is a geological eye blink, the signature we leave will be indistinguishable to anyone who comes after and develops the capacity to read it from the signature of any previous event of this kind. They would not know it was us. They would debate whether it was volcanic, whether it was astronomical, whether it was the product of some entirely natural process that the physics of the planet occasionally produces without any intelligent agency involved. They would probably not ask whether it was a civilization. Just as we have not systematically asked whether the PETM was a civilization. The question has been asked once, formally, by two scientists who secured no funding for the asking. The tests they proposed have not been performed. The sediments of the PETM have not been examined for the specific markers, plutonium isotopes, synthetic organic compounds, precise patterns of metal deposition, that would distinguish an industrial origin from a natural one. No one is looking. This is not because the scientific community has examined the hypothesis and found it wanting. It is because examining the hypothesis requires acknowledging that it might yield a positive result. And a positive result, anomalies in PETM sediments that cannot be explained by any natural process, that are consistent with an industrial origin, would require the complete reorganization of everything we believe about the history of complex life on Earth. The incentive structure of science does not reward this. The journals that might publish the results would be uncomfortable with the implications. The researchers whose entire careers were built on specific models of the PETM would need to revise those models. The popular narrative of humanity as the first complex technological civilization this planet has produced, a narrative so embedded in how we understand our own significance that questioning it feels like questioning ourselves, would need to be revised. And so, the sediments sit, undisturbed, containing whatever they contain. The rock remembers everything. We have not yet had the courage to ask it what it knows. There are a few things that must be said carefully here, because the question of honesty requires it. Göbekli Tepe is real. Its date is real. Its builders were real humans, as human as we are, and they achieved something extraordinary with the means available to them. The standard archaeological interpretation, that it represents the organizational capacity of complex hunter-gatherer societies, possibly organized around a regional ritual center rather than daily subsistence, is the explanation that the evidence most directly supports. The extraordinary builders of Göbekli Tepe were not remnants of a lost super-civilization. They were our ancestors, and their achievement, without the aid of any inherited advanced technology, is more remarkable for being entirely their own. The Younger Dryas impact hypothesis is real, contested, and genuinely scientifically significant regardless of its ultimate verdict. The evidence for a 12,900-year-old impact layer across 4 continents is real evidence evaluated by real scientists. Whether it represents a cosmic impact or has another explanation is an open question with ongoing research on both sides. The PETM is real. Its anomalies are real. The carbon isotope excursion is real. The abrupt onset, possibly as fast as 13 years in some interpretations, is disputed but real as a finding in specific sediment records. The Silurian hypothesis is real. Schmidt and Frank are real scientists. Their paper is real science. Their conclusion, that we probably cannot distinguish the geological signature of a short-lived industrial civilization from a severe natural warming event, and in that the PETM has characteristics consistent with both, is a real scientific conclusion published in a real peer-reviewed journal. What is speculative is the interpretation that connects these real elements into a coherent picture of something that came before us. The connection is not proven. It may never be proven. The geological record may have destroyed the evidence that would resolve it. But the question Schmidt and Frank asked deserves more than the one paper they wrote. It deserves the tests they proposed. It deserves the sediment analyses of the PETM that have not been conducted. It deserves the search for plutonium isotopes that has not been funded. It deserves the systematic examination of every anomaly in the geological record that matches the pattern of an industrial civilization's fingerprint, but looking for the specific markers that would distinguish it from natural processes. It deserves to be asked out loud, because if the answer is no, if the PETM sediments show none of the markers of an industrial origin, if the search comes back empty, then we have simply confirmed what Schmidt and Frank already believe, that no previous civilization existed, that the PETM was entirely natural, that we are the first. And if the answer is something else, if even one anomaly survives that cannot be explained by any natural process that is consistent only with an industrial origin, then everything changes. The Fermi paradox becomes irrelevant. The question of whether intelligence is rare in the universe is answered, because the answer is already preserved in the rocks of our own planet. The mirror continues to be held up every year. The human industrial civilization writes more deeply into the geological record. Every year, the signal we are creating becomes more impossible to miss. Every year that passes is another year that we spend burning fossil fuels and releasing heavy metals and disrupting the nitrogen cycle and building structures that will be in 10 million years nothing more than anomalies in the chemistry of the sediments above and below. We are writing the same record. The question is whether we are writing it for the first time. The rock will know. The rock always knows. Whether we have the courage to ask it is a different question, one that so far we have mostly chosen not to answer. Let me go deeper into several of these threads. Because the overview understates the specific technical details that make each one genuinely disturbing when examined closely. Begin with the fossilization rate, the number that makes the Silurian hypothesis not merely philosophically interesting, but empirically unanswerable with current methods, and that Schmidt and Frank placed at the center of their analysis. The fossil record is extraordinarily incomplete. Of all the organisms that have ever lived on Earth, across 3.8 billion years of life's history, the fraction that left any fossil trace is estimated at less than 0.1%. Of those fossilized, the fraction that has been discovered and described by paleontologists is a small fraction of a small fraction. The vast majority of Earth's living history is simply gone, decomposed, yes, recycled by the chemistry of the biosphere and the geology of the crust, leaving no trace that any instrument has yet found. For intelligent organisms capable of building technology, the situation is even more extreme. The human skeleton is relatively robust and can fossilize under the right conditions. But humans are large-brained, small-bodied animals, and large-brained, small-bodied animals are rare in the fossil record, even when they exist in enormous numbers. Our species, Homo sapiens, has existed for approximately 300,000 years. Of those 300,000 years of existence, the period from which we have significant skeletal fossil evidence spans perhaps 100,000 years and encompasses a few hundred individual specimens. A few hundred individuals out of the billions of humans who have lived in that time. Yet that is the completeness of the fossil record for our own species. Now ask, if a species of comparable or greater intelligence had existed, not for 300,000 years, but for 100,000 years, and then gone extinct 56 million years ago, how many fossils would we expect to find? Schmidt and Frank calculated this. The answer is approximately 1 in 1.3 million, the probability of any individual organism becoming a recognizable fossil, accounting for decomposition, geological recycling, and the fraction of Earth's surface that has exposed rocks from the relevant time period. For an intelligent species with a global population of perhaps 10 million individuals, comparable to early human populations, the expected number of preserved identifiable fossils from 56 million years ago is less than 10, possibly 0, probably 0. Yet, given that the specific geological formations from 56 million years ago that are exposed at the surface and accessible to paleontologists represent a tiny and unrepresentative sample of what existed at that time. We would not find the bones, we would not find the structures. Anything built of organic materials would be long gone, and even stone structures, unless they happen to be buried in exactly the right conditions, in exactly the right geological settings, would have been crushed, eroded, subducted, or resurfaced beyond recognition over 56 million years of active geology. What we might find, what might survive, is the chemistry. The carbon isotope anomaly, the heavy metal spikes, the nitrogen cycle signature. And those are exactly what we find in the PETM. The specific metals deserve attention because they are more telling than the carbon. The PETM shows elevated concentrations of vanadium, zinc, molybdenum, chromium in sediment sections from multiple locations around the world. These metals are released by industrial processes. The burning of coal releases vanadium. Zinc and chromium are common industrial effluents. Molybdenum is used in steel manufacturing. Their elevated concentrations in the geological record of the current era, the Anthropocene, are one of the markers Schmidt and Frank identify as the fingerprint of industrial activity. The PETM shows the same metals elevated at the same boundary. The natural explanation is volcanic activity. These metals are also released by large volcanic eruptions. And the North Atlantic igneous province eruptions that may have initiated the PETM are a plausible source. But the volcanic hypothesis faces its own timing problems. The rate of carbon release required to explain the PETM, especially in the shorter duration interpretations, exceeds what can easily be attributed to even massive volcanic activity, and the isotopic composition of the carbon is more consistent with an organic carbon source than with purely volcanic outgassing. Something released a very large amount of carbon from an organic reservoir very quickly, 56 million years ago. And the chemical record of that release looks like what our civilization is currently doing to the planet. Now, consider the scale of the PETM extinction. Between 30 and 50% of benthic foraminifera, The tiny shelled organisms that live on and in the ocean sediment, went extinct during the PIT. This is often understated in descriptions of the event, possibly because the organisms involved are not charismatic, but a 30 to 50% extinction of any major biological group is by the standards of mass extinction science, a major event. It is not as large as the end Cretaceous extinction that killed the non-avian dinosaurs, but it is comparable to several other events in Earth's history that are classified as mass extinctions. What killed the benthic foraminifera was ocean acidification and warming. The massive injection of carbon into the atmosphere was absorbed by the ocean, lowering its pH, making it more acidic, in a way that dissolved the calcium carbonate shells of organisms that rely on them. This is exactly what is happening in the current oceans as a result of human carbon emissions. Ocean acidification is one of the most serious consequences of industrial carbon release, and the PETM provides the closest geological analog we have for what a future of continued high emissions might look like for ocean chemistry. The parallel is not subtle, it is precise. The carbon isotope signature, the temperature increase, the ocean acidification, the selective extinction of carbonate-shelled organisms. These are the same phenomena in the PETM and in the current Anthropocene. The only known difference is the timescale. The PETM occurred over thousands of years at minimum, while the current event is occurring over centuries, unless, of course, the high-resolution interpretations are correct and the PETM really did begin in 13 years. In which case the timescale matches too. The Oklo reactor deserves specific mention because it is one of the most unusual objects in the geological record, and its implications for the Silurian hypothesis are rarely discussed. In 1972, French physicists discovered that uranium ore deposits at Oklo in Gabon, West Africa, contained uranium-235 at lower concentrations than expected. Concentrations consistent with uranium that had already been through a fission reaction. Analysis of the surrounding rock revealed the presence of fission products in exactly the pattern expected from natural nuclear reactions. The Oklo uranium deposit had spontaneously achieved nuclear criticality approximately 1.7 billion years ago, when the concentration of fissile U-235 in natural uranium was high enough to sustain a chain reaction, with water seeping through the rock serving as the moderator. The Oklo reactor operated intermittently for approximately 150,000 years and produced fission products, nuclear waste in effect, that are now preserved in the surrounding rock. Studies have shown that after 1.7 billion years, the fission products at Oklo have migrated less than 10 meters from their point of origin. They are still essentially where the reactor produced them, despite nearly 2 billion years of groundwater flow and geological activity. This has a specific implication that Schmidt and Frank noted. Nuclear waste from an artificial reactor, if it had existed anywhere on Earth 56 million years ago, would still be detectable. Not all of it. Some isotopes have short enough half-lives that they would have completely decayed. But plutonium-244, with a half-life of 80 million years, would retain approximately half of its original quantity after 56 million years. If a civilization had built and operated nuclear reactors 56 million years ago, the waste from those reactors, if preserved in a geological context similar to Oklo, would be detectable today. The PETM sediments have not been examined for plutonium-244. The test has been proposed. It has not been funded. It has not been done. This is the specific scientific gap at the center of the Silurian hypothesis, not the speculative interpretation of the PETM as a possible industrial event. That interpretation is probably wrong, and as Schmidt and Frank themselves believe, but the systematic absence of the test that would definitively answer whether it is wrong. The test that would transform the question from an interesting thought experiment into a resolved scientific question. The cost of searching for Pu-244 in PETM sediment cores is not prohibitive. It requires isotopic mass spectrometry of the kind routinely performed in nuclear chemistry laboratories. The cores exist. Ocean drilling programs have collected sediment cores that span the PETM horizon from multiple locations around the globe. The test could be performed on existing archived material. It has not been proposed as a funded research project, No grant application has been submitted. Consider what that means. There is a specific scientific test, yet proposed in a peer-reviewed paper by credentialed scientists working at NASA and the University of Rochester, that could definitively characterize one of the most important open questions in the history of science. Did any form of industrial civilization predate humanity? And the test has not been funded, not been performed, not been seriously pursued. Why? The most charitable interpretation is that the scientific community correctly assessed the probability of a positive result as too low to justify the investment. Schmidt and Frank themselves believe a previous industrial civilization probably did not exist. Allocating resources to a low probability investigation when higher probability investigations compete for the same limited funding is a reasonable choice. The less charitable interpretation is that the scientific community has assessed the discomfort of a positive result as too high to risk the investigation. A positive result, even a single anomalous finding in PETM sediments that cannot be explained by any natural process, would require a response that no scientific institution is currently structured or motivated to provide. The truth is probably the first interpretation, with a component of the second. But what matters is the result of either interpretation. The test has not been done. And as long as the test has not been done, the most honest, scientific statement about whether an industrial civilization preceded our own is not no. It is, we do not know, because we have not looked in the right way. We have not looked in the right way. 56 million years of silence. The rock remembers everything. We have not yet had the courage, or the curiosity, or the funding, or the institutional will to ask it the right question. And every year we burn fossil fuels, we write our own version of that silence more deeply into the record. Future scientists, if future scientists exist, will find our layer. They will find the carbon anomaly and the heavy metals and the extinction pulse and the ocean acidification record. They will debate its cause. They will propose volcanic explanations and astronomical explanations. Whether they propose an industrial explanation will depend on whether someone, before our civilization ends or transforms beyond recognition, decides to make the case for looking. Schmidt and Frank made it in 2018, in a paper funded by no one, sought by no one, followed up by no one. Now the rock remembers. We are choosing to forget. There is one final thread in this story that I want to pull carefully, because it connects all of the geological and archaeological evidence to a philosophical question that is, in the end, more disturbing than any of the individual pieces. The question is about the nature of time and civilization. We tend to think of our civilization as the endpoint of a long evolutionary process, the culmination of billions of years of biological evolution and hundreds of thousands of years of human cognitive development. The narrative of human history as we understand it is a narrative of progressive development. From hunter-gatherers to agriculture to cities to industry to space travel, each stage building on the last, each generation more capable and more knowledgeable than the previous one. This narrative has been so consistently confirmed by archaeology. We find older tools simpler than younger ones, older settlements smaller than later ones, older art less technically sophisticated than more recent art, that it feels like a fundamental feature of the universe rather than an artifact of the specific history we happen to inhabit. But the narrative depends on a specific starting assumption, that our civilization is the first. If our civilization is not the first, if any form of complex industrial civilization has existed before, however briefly, at any point in Earth's 3.8 billion year history of complex life, then the narrative changes entirely. The endpoint becomes one instance in a sequence. The progressive development of human civilization becomes not the direction of history, but a pattern that may recur. The question of what happened to the previous instance, why it ended, how quickly it ended, what it left behind, becomes the most important question we could ask about our own future. Because if a previous industrial civilization existed and ended quickly enough that its geological signature resembles a severe natural event rather than a civilization's footprint, then the question of how it ended is not merely historical, it is predictive. It tells us something about what civilizations do to themselves or to their planets, or what their planets do to them. The most disturbing version of this possibility is not that a previous civilization was destroyed by an asteroid or a supervolcano. Those are external catastrophes that tell us little about the internal dynamics of industrial civilizations. That's the most disturbing version is the one implied by the PETM's carbon signature, that a previous civilization ended because of what it was doing to its own atmosphere, that the geological record of a previous civilization's existence and the geological record of that civilization's extinction are the same record, the same carbon anomaly, the same temperature spike, the same ocean acidification event, the same extinction pulse, that the cause and the consequence are written in the same layer of rock, and that we are writing the same layer right now. Schmidt and Frank acknowledged this in their paper more quietly than the implication deserves. They noted that the current Anthropocene is creating exactly the geological signature they describe as the footprint of a short-lived industrial civilization. And that the PETM shows analogous signatures. They did not draw the explicit parallel. They did not need to. The comparison is available to anyone who reads the paper with the right question already in mind. We are creating the record that a future scientific civilization, if one exists, will examine and debate. We are creating the anomaly in the geological column that might, 56 million years from now, be described in papers like the one Schmidt and Frank wrote. Papers that will list the natural explanations and find them incomplete. Papers that will propose the industrial hypothesis tentatively, cautiously, with appropriate scientific hedging. Papers that will propose the test that would resolve the question definitively. And those future papers might note, and as Schmidt and Frank noted about our own situation, no funding has been provided nor sought for this study. The rock will remember what we did. The question is whether any future scientist will be curious enough, and honest enough, and brave enough to ask why the record looks the way it does. The question is whether any future scientist will exist to ask it. The rock is not optimistic or pessimistic about this. The rock is indifferent. The rock records what happens and preserves it in the chemistry of its minerals and the ratios of its isotopes for as long as the geology of the planet permits. The rock has done this before. 56 million years ago, something happened. The rock recorded it. The chemistry is there. In cores drilled from the ocean floor and from outcrops in New Jersey, and in sediment sections from Spain and Egypt and the Pacific and wherever geologists have looked for it. The rock says something released a lot of carbon very quickly from an organic source and then stopped, and then the world slowly recovered. Over tens of thousands of years, the carbon was drawn down, the oceans realkalized, the temperatures fell, the extinct species were replaced by new ones. Life continued, as it always continues, in the forms that survived whatever happened. And 56 million years later, one of the new species developed the capacity to read what the rock recorded, and wrote one paper about what it might mean, and then got busy with other things. The rock is still there, still recording, still waiting for the question to be asked correctly. But we have the instruments, we have the cores, we have the laboratories, we have the scientists. We have not yet decided that the answer matters enough to look for it. That decision, whether to look, whether to fund the search, whether to ask the rock what it knows, is ours to make. It is one of the few questions whose answer could change everything we believe about who we are, where we come from, and what is likely to happen to us. And it is being made by default every day by the absence of a decision. The rock remembers. We are choosing, for now, not to ask.